Hey, welcome to the D&L Guy. Ask the D&L Guy at gmail.com. I got a question this morning and I wanted to answer it. So, what is the difference between efficiencies on gas and propane furnaces? We're going to learn that today on Ask the D&L Guy. So, you got a gas furnace in your home. You want to know what the efficiency is on that gas furnace, right? Okay, well, I'm here to tell you. It's very, very simple. We have an 80% gas furnace, we have a 90% gas furnace, we have a 92% gas furnace, and we have a 96% gas furnaces. So don't get all tensed up with all these choices that you have. You got to rely on your HVAC contractor, such as the D&L Guy, to properly size and put the right gas furnace in your home. Okay? So this is how we're going to do it. 80% gas furnaces. Number one thing on that has a single stack pipe that comes up. Normally it's made out of aluminum, steel, double wall pipe. Anytime it penetrates the ceiling or roof, it's always double wall. Coming off the furnace, single wall pipe, okay? Normally silver in color. That's an 80% furnace, okay? So now we move up to a 90%, 92 or 96. Is going to have two pipes. One is going to be your air intake, one is going to be your exhaust out. Normally that's going to be PVC pipe. It's going to be white pipe. Now, you could have one pipe going outside, or you could and one pipe inside, or two pipes going up and outside. There are certain times that on a 90 to 92% furnace, you will have an air intake inside the mechanical room or basement, okay? And the reason for that is we have enough combustible outside air that we can bring in there as fresh air, okay? What I've seen a lot, and which is a huge problem, is in these customers' homes, when the house was built, the basement wasn't finished. So what did they do? They put these 90% gas furnaces in there with one air intake in for the basement, sucking all the air from the basement as combustible air. No. What homeowners then renovated and finished the basement off, made a mechanical room downstairs and left this furnace in there. Guess what? It's wrong. It's wrong. And nobody told them this. These furnaces, they'll put a water heater that's gas and a gas furnace beside each other. They both have to take the same combustible air. And it's a no-no. Because if one unit is running and the other one starts up, it is going to suck the air coming out of the stack pipe into the furnace. Or vice versa, out of your furnace into your stack pipe or your water heater. You have to get outside air to this equipment inside of a mechanical room. Unless your mechanical room is big enough in square footage, and this has to be by code. This is code. We have to go back to the manufacturer and look at how much air intake does that furnace require. So when you get up into a higher percentage, like a 92, 94, 96, it is going to require more combustible air coming in because it fires more efficiently. The more air, the more fuel. We can blend it together and we get great efficiency out of it. So, efficiencies. How do they determine the efficiencies? So on an 80% furnace, what is 80% mean? What does it mean? What does 90% mean? What does 92 and 96 mean? Okay, so what I'm about to tell you is going to be mind-blowing. It's going to be mind-blowing because if you have an 80% furnace that has 75,000 BTUs, we'll use 100,000 for round numbers, okay, to make it easy. You will only get 80% of that 100,000 BTUs. So you get 80% of what your input is. Now, that's not your output, that's your input. So by manufacturers, they say, we have an input of 100,000, we have an output 80% of that. similar to 90%, 92%. So how is that calculated? Well, let's go over to the whiteboard and I'll show you, because this is where it's going to be interesting, and you'll learn so much about your furnaces and how to read what is an 80%, 90%, or 92%, okay? So follow me over here. We're going to take a look. So on our whiteboard today, we have an 80% furnace right here, 80%, right? So what we're going to do is we're going to look at the efficiency of that 80%. How do we determine that? Let's say we'll use round numbers, and those round numbers is 100,000 BTUs. So on 100,000 BTUs, we're only going to get 80% of that. So what do? You take the 100,000 and multiply that by 80%. And that will give you your efficiency of that furnace. And if my math is correct, times 80% gives you a number of 80,000 BTU output. So when they say you got a 100,000 BTU furnace, you really only get an output of 80,000 BTUs. So, and then same thing with a 90% furnace. So you do the same exact math. If you had 100,000 BTUs going input and you multiply that by 90%, you'll get 90,000 BTUs out. It's 10% less of 100. You'll get 90,000 output. Same thing on 92 and 96, same exact way. If you had 100,000 for 92, you'll get 92,000 output. Because 92,000, if you subtract 92,000, it's 8%. You're losing the efficiency of what it is. This one here, 96, you're going to lose 4,000 BTUs. You'll get 96,000 output. That's how they determine the efficiency of your gas furnace and whether or not. So now let's take a look at what I said to you earlier. You have a furnace. Now I will say this, I'm no Bill Cosby, picture pages, but you'll have a single wall pipe coming out of the top like this, and it may go up and it goes into your ceiling here. And that is your exhaust gas out, okay? So on the 90%, you're going to have a furnace that has an air intake that may be into the mechanical room, and then this one has to exhaust out and may go up to the roof of the house. It may go out through the ceiling of your basement and then come out the wall outside, or you'll get up into the 92 and 96s where you'll have two pipes that will pretty much follow each other, coming out one on each side, and they'll kind of follow each other and go up to the roof. One is your air intake, which we can mark this one as air intake coming in, and this one is your air going out. Exhaust intake. So on the higher efficiency ones, you have to have air coming in from the outside and air going out, exhausting out. There's an induction draft motor inside here that spins and pushes all the non-combustibles outside that pipe. So furnace efficiency is very important in determining what is required in your home. So let's say, for instance, you have an 80% furnace in your home right now, and you wanted to upgrade to a better efficiency furnace. Two things you need to know about it. It can be done with no issues at all. If you have an unfinished basement, that is perfect because the PVC piping can be run for your exhaust and for your intake. If you have an unfinished basement, if you have a finished basement, it becomes more difficult because that piping cannot be run. Some drywall modifications are going to have to be made. You may have to cut into the ceiling to move the pipes. You know, you've got to get that air outside. So if there's a way of doing this without raising the cost up so much, then yes, you can upgrade to these, and this pipe, the 80% would actually just be capped off. We would cap that off right here. We would then turn and run a 90% furnace in your home. Now, the BTUs of the furnace obviously is based on what's required to heat your home, okay? So how do we determine that? A load calculation is done on your house. Now, and I'm gonna say this with all due respect, and I'm gonna say this why a lot of people may disagree, and that's okay, you can. But when houses were built 10, 15 years ago, we didn't have the technology we have today. So what was put in these homes were probably overkill. We ran into one the other day, a little story that the house was built back in the 70s and it had 100,000 BTU furnace in this home. The house was only 2,000 square foot. There is no way that that furnace was the proper size for that. So we had to do a load calculation. And do you know that that house only required 56,000 BTUs of heating? And the reason why it only needed that is because the original calculations weren't done properly. We found out later on that one of the issues was that a friend of a friend of a friend happened to have this equipment, and they got it really, really cheap and got it installed cheap, and it never worked properly. Can you imagine the gas bill over the last 20 years that they had to pay for to run a 100,000 BTU furnace that they only needed to run 50,000, 60,000 BTUs? So that's where you need to be careful when people are changing your gas furnace. They have to be qualified to do what they call a manual J. A manual J on residential is a calculation of the heat and cooling load that's required for your home, okay? So next time you need your equipment serviced or you need it replaced, make sure that that HVAC company, whoever it may be, doesn't matter, does a manual J on your home. Because you may find out that the original heating system that was put in there was either put in there, the calculation was wrong, or was put in there improperly, okay? So that's our tip for today. Remember, subscribe to our YouTube channel, that red button that says subscribe. D&L Mechanical Services on YouTube. Visit us on our Facebook page at D&L Mechanical. Send your questions to Ask the D&L Guy at askthednlguy@gmail.com. And until next time, I hope you enjoy the video. Give us a like, click that, subscribe, and we'll see you soon. Thanks, guys. Take care.